Welcome. Thanks for everybody for coming out tonight. Thank you, Meetup, for hosting us once again. And so we have Danny Loya of Lab 49 out. He's going to be talking about testing web applications with Java and reliability, best practices, as well. I'm sure he'll discuss his framework, DollarX. So welcome, Danny.
So this is actually based on a presentation I gave in the Java meetup. But I can, first of all, I just want to verify. I assume most of you are quite familiar with Selenium already, since this is a Selenium group. So I'll skip that part relatively. I go through that part relatively quickly. My focus will be around Java, or if you want, Scala. How many here are familiar with Scala? I just need to know that. And how many are familiar with Java? Okay, so obviously most people are familiar with Java. Okay, that's good. So yeah, I'll talk a little bit about Lab 49. So Lab 49 is a relatively boutique consulting company. We work with the financial sector. That means basically big banks, big hedge funds. We do some really cool projects using really cutting-edge technologies, and we are hiring. That's all. So if I don't look too stupid and you want to collaborate, come aboard. So that's it. Now, if you have any questions, feel free to address this. It will be, it's meant to be relatively interactive, okay? So, okay, let's go. So my agenda is introduction that we will go over quickly, since you probably know that stuff. And then, we'll talk a little bit about finding and interacting with web elements. Again, most of you probably know the basics, so I'll go over it quickly. And you can guide me, okay? And if you tell me if this is too slow, I'll speed up, okay? Now, how do we perform assertions? Next. Anti-patterns and gotchas, these are very important. This is an important part, right? A lot of things that we tend to do often are actually bad things, and we'll get to that. And then we'll get to the $X library, which I wrote, and it's an open source. Even, I don't mind if you don't use it, it's fine. I just present it as an option to learn from, even if you don't use, that's fine. We'll see some code examples. Now, what I'm not going to talk about, I'm not going to talk about specific testing frameworks, because that's not what it's about. I'm not going to talk about Cucumber, yes or no, or Robot, or any other frameworks like that. I'm not going to talk about Protractor or Jasmine, and other JavaScript tools. And I'm not going to talk about visual testing. I'm just going to talk about functional testing, okay? Meaning interacting with DOM elements, okay? So when I first started to work on testing web applications, I heard from fairly competent engineers some reactions, and these are common myths. Number one, that it's extremely slow. Now, when you say extremely slow, obviously one test is not slow, but let's say you want to write behavior tests and you have, it's realistic to have 5,000 and 10,000 scenarios. This is not an unrealistic case. And when you run all of this can be extremely slow. To the extent that it's just not practical. I don't want to run tests and come back several days after that to see if they passed successfully or not. Another thing is we have a lot of race conditions, right? And especially in the in the new web frameworks that update the DOM in a smart way. So talking about Angular, you're talking about React, Ember. These frameworks keep updating the web in place. And because of that, they create race conditions for the tester. Because of these race conditions, the tests, in many cases, just, they don't always have the same results. You can have tests that 95% of the time it passes and 5% it doesn't pass. So you either ignore the failure, which is obviously bad, or turn it off, which is doubly bad, or let's put a sleep there, right? Let's put sleep 5 seconds. Maybe that will solve magically the problem. That's not a good approach, right? Next, it's very expensive to maintain. Okay, you probably know that stuff. It's very expensive to write and maintain good tests for web applications. It tends to be very brittle, whether you work with CSS or XPath or whatever other frameworks you're using. Next, for all these reasons, basically just use it for smoke tests. That's the idea. Just touch it, play with a web page a little bit, see that it kind of works, and that's it. That's a very common approach. Now, I'm in the right group. Hopefully that you don't agree with that. So what's the challenge here? We have multiple challenges, basically. First of all, we need to write correct code, and that's not obvious all the time. For example, let's say we want to find that a certain DOM element contains somewhere inside it, I don't know where, but somewhere inside it, a test that if you aggregate it, conforms to some regular expression. Okay, and let's say, so that's not an easy thing to do. I mean, next, we talked about expensive. Because of that, it's not an easy thing to do. What ends up happening many times is, someone would write something and it will be completely unmaintainable and very brittle. So that's the next step, right? And the next person who reads the code, what the hell is going on here, right? You've probably all seen that. Race conditions and other gotcha. As I mentioned before, in the past, in the days of, like if you go back 10, 15 years ago, when web frameworks were generally static, it was actually, that was not so much of a problem because it loaded everything from the server, and then the DOM was kind of static at this point until it loaded another page. Now, with single-page apps, that's not the case at all. It's the complete opposite. It keeps updating the DOM on the fly. And if you look, if you missed 1 second maybe, and you didn't look, you blinked, then you missed what you were expecting, right? So that's the concern. We talked about performance, right? We mentioned it earlier. It's not, because of all the reasons we mentioned earlier, it's not easy to write a web. It's very easy to write a badly performant test. Okay, it's extremely easy to write, and we will see examples later. Code that looks very innocent and has terrible performance. Okay, that's something we need to watch out for. Assertions. Writing proper assertions is not easy, both from the perspective of writing correct assertions, but also assertions that provide you something useful in case they fail. Okay? Because let's say, we will see some examples later, But let's say you get, you use Selenium, and you look for a certain element, and then you get something like element not found exception. Not very helpful, right? For someone who doesn't know exactly what your code does. And then that's related to the sixth section as well, troubleshooting. When a test is broken, how do I troubleshoot it easily? Typically, what you would end up doing, you'll start copy-pasting CSS path and XPath to the developer studio in Chrome or whatever you're using, and it's just tedious. Okay? Yeah. So quickly, this stuff I think. So what do we do in tests? That's just true for any test, right? We perform actions in the browser. So this is, if you talk about the Gherkin approach, that's like the given and the when, okay? If you're familiar with Gherkin. Typically, we find an expected element in the DOM, and then we do something with that, okay? And the next step is we assert that the DOM matches some expected some expectations. So that's the then part. What it can be an existing element, whether it exists or it doesn't exist. It can be some attribute of the element, text, visibility, is it visible or not. It can be the number of elements that you see, things like that, right? So far, we are all on the same page, right? Yeah. How do we interact with the browser? We do it through Selenium. You know about Selenium. I can go over this, right? I mean, this is stuff that you probably know very well. Or do you want me to? If you would like, I will go over it. Okay. Okay, I'll just go over it quickly. So it's done through Selenium, okay? Selenium has a wire protocol. It's well documented. And there are APIs, well-known APIs. The most famous ones are the Java and the JavaScript API. The Java is called WebDriver. In the JavaScript, you have WebDriver.js, or the most recent one, WebDriver.io. In the past, it used to be called Selenium RC, which was Selenium 1. And what it used to do, it used to inject JavaScript to the browser. Then the Selenium guys decided that's not a good approach. We'll talk about later why. Selenium WebDriver is Selenium 2. What it does, it actually uses the native API of the browser. So it bypasses the JavaScript engine directly to the C++ engine, okay, typically. So the performance is much better. Any idea why the Selenium guys decided that it's probably not a good idea to inject JavaScript?
It's slow.
Sorry? Slow, that's right. Number one, it's slow, correct.
I didn't hear that. What did he say?
He said it's slow. It will be slower, correct. But there's one more thing. So how would you feel, Java people, if I said, I'm going to write a test for your Java, but what I'm going to do, I'm going to inject code that will change your code running on the JVM, ignoring any defenses that you have, any security you have in the code, and that's how I'm going to test your code. You'd say, you're crazy. That's not how you test code, right? And basically, that's what you're doing with injecting JavaScript, right? You're basically, I can do anything I want to the application and completely destroy it, if I wanted to, by injecting JavaScript. So that's not a very healthy approach. Okay, you want to treat it as a black box. Basically, you want to treat the application as a black box. So you can't really interact with the execution code. But that's not possible when you inject JavaScript. So the browser can either be headless or one of the usual browsers we use. You know probably this stuff, Phantom, things like that. It's very useful when you have continuous integration, continuous deployment. Other nice tools to be familiar with is Source Lab Selenium Grid and Applitools Eyes. Anyone heard about Applitools? If you haven't, it's a really cool tool. Okay, but that, as I said, that addresses more the also the visible aspects, so it will look exactly as you would expect, including CSS and everything. Okay, I'm not going to talk about Applitools. Okay, so I'm going to talk about this, and you'll tell me if I'm being too slow. Okay. 3 components in Selenium, right? You have the client, you have the server, you have the browser. The client is basically a library you run in your test executable, right? So it would be, in Java world, it will be a WebDriver client. In JavaScript, it will be something else that actually, I think actually behind the scene, it's a WebDriver client. That's it. Now, this WebDriver client will call a WebDriver server. The WebDriver server is an adapter between the Selenium wire protocol and the specific protocol, proprietary protocol of the browser. So, as you would expect, each browser has its own WebDriver server. And you have the browser that actually runs the application. So it looks like that, right? You have your tests on the left. Inside it, you have the library of the WebDriver client. And then it uses any of the servers of the Selenium servers, which interact with the browsers. So let's take an example. Yeah. So we create a new driver server. So when we call Chrome driver, it will actually run a new executable. It will find the Chrome driver based on the Chrome capabilities that you pass here. And then I think also at that point, it will try to establish a session with the browser. It will see it doesn't have a session with the browser, so it will run a browser in order to establish a session. Okay? So after the first line, the first command, you have a browser running, you have a server running, and obviously your test. And then you can start calling commands. You have a session open. You can start doing stuff. So you can go to some web page and find an element. Okay? That's stuff that, and then you can send keys to that element. Okay? People are generally familiar with the code like this? Okay. Yes?
Is it in particular the probe driver you gave the path to the executable?
Yeah, so it's in the Chrome capabilities.
But other drivers still need paths, just particularly.
I think they need it. I think they need to know where it is, or maybe I'm not sure about this. Maybe it can be in the environment. I don't remember exactly. Okay. I'm sorry?
It's using get code driver.
Okay.
No, it changed.
So, okay, at this point, let's go a step deeper. We understand roughly how it works. So we need to wait, right, when we interact with elements. That's one of the problems. So you go to a web page, you need to see that the web page has loaded. There are two ways to wait, explicitly and implicitly. Explicitly, you can just create a wait object. And I'm saying, okay, this wait object refers to my driver, and the length is 10 seconds. And then you use that, and explicitly you say, wait until some condition is met. Okay? So you can read what that means. It's pretty obvious. Alternatively, and I think it's a bit more elegant, you can use implicit wait, and then you can use just you can still change it, but you don't need to declare it every time. And whenever you want to change it, you use that API. Okay, so I change it now to 5 seconds. And every time I will call something, it will wait 5 seconds. I mean, maximum 5 seconds. Anyone wanted to ask anything? Okay. So, yeah. So how do we troubleshoot test? Many people, unfortunately, forget the fact that the browser process is completely independent from the test code. That means that you can put a breakpoint in the test code, and the browser still runs. Okay, so if you want to look in the DOM while you put a breakpoint in the test, then look at the DOM or go to another page in your app, that's perfectly fine. That would work, no problem. Okay, there's nothing wrong with that, and that's very useful to do. Another thing you can do is just screen capture using assertion error messages. Obviously, the regular assertion, what comes out of the box with Selenium, not great. We'll talk about this, but you can wrap it with something of your own. Then we can capture the inner HTML body and show it, and we can look at the log of the browser or Selenium. That's also useful because it tells exactly what happened, what it did. Let's take a simple example. So how do we find an element? Span inside div. The div has class foo_buzz and ID the ID. The span has class bar with text John. We want to find span. So we can look by ID or class or tag, right? So driver find element by whatever you want to look, and here it's the ID. So we look for that ID. At this point, what's inside div? After this line.
You asked a question?
What's inside div? What is div equal to? After the first line.
You can find it through either the class bar and then the text, which is John.
Yeah, but I'm asking after this line, what's inside div? After the first line.
The elements. The div and the span.
Inside div is just a pointer. Think about it, or a reference number. It's a reference. That's all. There's nothing inside it. It's important to remember. We'll get to this later. Okay? Now, what we are saying, okay, now, browser, starting from div, anything from div, look for an element with class name bar, and that will return span, right? So we have two steps. This went to the browser twice, right? Obviously. We can also use CSS selectors. which allow us to do it, more compactly, I would say. For example, whatever is written here, we can do it in one line, right? By CSS selector, the ID, this is the CSS selector of this. The ID and the class name with a dot before it. Or alternatively, you can use something like div.foo, which gets me the div with class foo, and inside it span.bar, which gives me the span with a class bar. Okay. Now, the most powerful way, and we will see later why, is to use XPath. Okay, that's the recommended approach. XPath is by far the most expressive DSL, I would say, to use.
It's also the slowest, right?
No?
XPath is slow.
No?
Yes.
Okay. Okay.
We've tried XPath and it is really slow. Because XPath, especially if you're doing an element and then you find an element under that,
That's
XPath
not-
searches the whole thing still.
So that's not related to XPath, that's related to how you wrote it, that you went through all the elements. We'll talk about.
No, even if, like the example you just gave, if you were to change that to XPath, it'll take a lot longer than CSS selector.
Okay. Do you have proof?
If you put expert, which can have multiple options, goes iterate through each of them to find proper value, it takes a lot. But if you make more specific expert, where there is more different, like where you specify a pair, just only one pair to go, it would be much faster.
So XPath is faster than CSS, and you can check it. If you use the XPath, you can use XPath that it will be terribly slow, and we'll talk about this in a minute. And then, toward the end, we can talk about this. Okay.
Also, when you use the find element, you're assuming that you're returning one result. If you have used expert that has multiple results, you have to use find elements.
So let's talk about this. I mean, you can always use find element. You can use for both, right? It has nothing to do with XPath, CSS, or whatever, right? Find element or find elements are unrelated to whether it's XPath or CSS or ID or class name. Okay, let's just give me 5 minutes and then let's come back to that. Okay, so let's take XPath. Okay. So I will just do remember the DOM we had? We had a div with class foo, and inside it we wanted the span. So I'll just write something like that, right? And what does this mean? That means go somewhere inside my DOM, that's a // find div, and then find the attribute class equals to foo. Okay, assuming I'm not fine, I'm sorry, in the condition that that attribute class equals to foo, and inside it, find span, and that will return, span. So, what do you think about that? Is this good? Selenium people, is this good? Why is it not good? Let's look at it again, I'm sorry. This is how it looks like, right? Full bars.
Guys, right?
Yep. Class is full bars.
To class foo, you should go for all div on your DOM page.
All what? I'm sorry?
On your DOM structure, you should go to each div. So if you specify what specific div on your structure you're talking about, let's say 4 or 5 child after second parents, for example.
Right, but you're talking about optimization right now. Okay, let's. Yeah, but is this correct?
The only code is correct.
I'm sorry?
If it's the only div, and if it's the only span ID, that's correct.
Yeah, but I'm asking about this. So that will fail.
Class,
And you said something.
class is incorrect.
Class is incorrect, right? The class is not foo. The class is foo buzz, right? So that will fail. So maybe we can improve that. How about this? If the class contains foo, what do you think now? Right? Is this good? Are we good?
Let me ask you a question. So the contains you're running, I guess a method that will start searching, right? Whether this class attribute does have foo in it, right? So, but in CSS selectors, you can basically just do div.foo to pick it up the div, and that will work. So you're saying that still this might be faster?
So let's talk about fast later, okay? So what do you think?
You have problems with have another tag which contains food,
So what about, yeah.
and it's not food bar, it's like tape or something like that. And it'll pull up that tag next to it.
So what about if I have a class, div with class, I don't know, full or not full. Okay, I have a class not full. That would match here. So that's not good, right? It's a false positive. So that's not good. Maybe I can do something better.
You start with,
I'm sorry?
starts with.
But maybe I don't know that it starts with. I just know it has full. Yeah, but I don't know that it starts with. I mean, it's perfectly okay if it will be the second one, as long as it has class foo, right? So let's try this for the third time. Okay, so this, what we do here, we do a trick. You know, we add to the class attribute space in the front and at the end, and then we say, then it should contain foo with spaces from both sides. If you think about that, that will solve our problem, our previous problem. Okay, that's correct. Now, that's not easy to think about alone. And that's almost correct. Actually, the right one is this, to use normalized space, because what about if it has insert spaces between them, it has tabs, or even enter, it's valid. New line, it's valid. So you should use normalized space. Now, I said XPath is great. This is not great, right? This is not something we want to deal with, okay? Okay, so let's,
I have a question.
yeah.
Why don't we just find the thing by ID? Give us an ID for that.
So you can use, we talked about ID, remember? In the beginning, we showed
The example that you're giving, like, there's an ID in the top element, so why don't we directly use that in the XPath?
we could. I just showed an example for, just to make a point. Okay, that's all.
Not always say be present, not all parameters say be against each other.
Okay, just so you know, ID for developers is an anti-pattern these days to use ID a lot.
It's what?
It's an anti-pattern considered to use ID a lot. As a developer, we prefer to use other attributes, such as classes. The problem with ID, it has to be globally unique. Okay, so if the ID is a generated unique ID, guaranteed unique ID, that's one thing, but it's probably not something you could use in a test. Okay, so generally IDs, yeah, most developers will not use IDs.
Do you still need it for accessibility though?
No, why? No.
I don't know, I thought it was part of the accessibility, standards, because you have those readers that people with handicaps use. I thought that those always needed like some sort of ID so that they could focus on the, deal.
So I have to admit I'm not familiar with something like that. Maybe it's something that I'm not aware of.
Okay, all right.
It doesn't.
It doesn't? Oh.
Some countries have regulations for like
people that are disabled to use that knowledge and they have to work with that.
Okay. So let's look at a quick example of how a code would look like. I lost my... Where's my, I lost my, oh, no. Cool. So this is just a common example of how it would look like. It's a bit small, right? So this is an example of using expert, okay? So, you create a driver, like we said, you go to some page, you find, let's say, Google in this case. This is using XPath. And then you start interacting with this. We send the keys Amazon, and then we verify that, it gave us the results we expect. Okay, you probably saw this code like this before. So we talked about find element. It's an important distinction. So both of them will block until they find at least one element or the predefined timeout has reached. And the difference is that find element will return, obviously, in that case, if let's say they found something, find element will return the first one. Find element, if there's more than one, will return a bunch, all of them. And in case of a timeout, find element throws an exception. Couldn't find it. Okay? Find element does not throw an exception. It just returns an empty collection. Okay? It's an important distinction when you use. Injecting JavaScript, we talked about this. When is it relevant to you to inject JavaScript? It might be a valid approach when you need to interact with a very smart adaptive component, and the only reasonable way to do it is to inject a script. Because otherwise it's just a nightmare to use repeatedly. Query the browser, do something, query the browser, do something, query the browser, do something. It can be much easier in that case to use JavaScript. But as I said, typically in 99% of the cases, you should not do this. The Selenium team decided that it's a bad idea. So, some assertions. An element exists, right? So we do find element is basically an assertion that an element exists, because if it can't find it, it will throw an exception, right? Element does not exist or exists n times. So let's take an example. Yeah. So this looks like a perfectly reasonable example, right? Get all the elements, that we look for, and assert that what you got is empty. The logic is sound, right? As far as Java. Anyone sees any problems here? I mentioned here, assuming we usually expect our assertions to be correct, what's the potential issue here? But I would even say, that's one thing, but let's say it fails. What happens when it fails? So that means it's not empty. Right? Fails meaning it's not empty. There are elements like that. So let's say, it fails hard. Let's say there are 1,000 elements like that. So it will go, get 1,000 elements, pass all the reference ID back to me, and then I basically throw it away. I say, oh crap, I don't need that. I wanted nothing. So that's kind of pointless. It's very expensive, and we didn't do anything, right? It's wasteful. It's a performance cost. What else? There are several problems here. What else do you see that is less than ideal? So let's say it's successful. Okay. So what will happen? So that means that this returns nothing. So what does it mean? It means that it waited until the timeout has reached, and then it moved to the next line, right? So here it waited. Let's say the timeout is 10 seconds. All is an empty list. Gets back an empty list, and then we assert that the empty list is empty. So the assertion is correct, but we just waited 10 seconds for nothing. Right? That's not very good, right? Now, what about the following scenario? Let's say we look at the table, and we expect the table to be empty. Someone clicked clear, and then we expect to see the table empty. But what if it took 1/10 of a second for the DOM to be cleared? Then we got the element, and we return immediately, and we got a bunch of rows. It's not empty. It failed. Okay? So we have a failure, but it's not really a failure because we were just too fast. Anything else you see?
You can capture it and then it becomes
I'm sorry. I'm sorry?
It becomes still. The item becomes still. You have counted it and then maybe it gets moved from the DOM and then it becomes empty.
So we only get to the browser once. So I think stale here is not a problem because we only go to the browser once. Okay? However, let's say it fails. What will I see as the error? I'm the tester. What will be the error? Can you tell me what will be the error? What will be the error message? I'm sorry? Right, but it will say, you're right, but the assertion error will be expected empty, not empty. Awesome. I have 5,000 tests. I see an error, expected empty, but not empty. Someone asks me, what's the problem in the website? Expected empty, not empty. That's completely useless, right? So that's another problem we have here. It's not a useful error.
Wouldn't that be fixed through the reporting?
What do you mean through the reporting?
Let's say you're using TestNG, that test would be also...
So you're right that you'll see the name of the test, we'll see red, let's say, failure of the name of the test.
It provides the information in the login.
But then so the information, what do you mean information in the login? You will see a stack trace.
So you write steps that you're doing in the back for your console log. And you're also writing a reporter log for your TestNG report. So that the reports that you're sending out to your team.
Yeah, I think that's what I do too, what you just said.
you just then like write like a function that does it for you. So that if it does still fail, it says where it failed and why, and then it keeps going.
But I understand what
Yeah,
you're saying.
but either you wrap it with something of your own, that's an option, or you will get something that says this test failed, but you don't know exactly what was the failure.
But wouldn't
Right.
you just do what you just said, and that way everyone kind of wins? Like I know it's a little bit more effort, but it's a win-win situation. Like it takes maybe like 5 more minutes.
But how do you know what was exactly the failure?
Because that's what you tell it to. Like, you just write like a function for it, saying like click here, do this. If if empty, then you say like like function catch error, console log
But
on this page.
but
on
what
this
about
thing,
if the application, let's say, crashed? You don't know what was the problem in the step unless you know the code. Okay, this is a very simple example,
Yeah.
but generally, yeah, I agree. You can wrap it with stuff and then, but that's work. Okay, I'm saying that as is, that's not useful. I'm not saying it's not addressable. Okay. Let's continue. So another kind of assertion that we do a lot is that the element has some property. Yeah. For example, assert that element getText equals to John. This is a perfectly reasonable code, broken. Why is it broken? It's broken. It has a bug. Okay? The bug here is we got the element, that's not an object, just a reference ID. Now you call getText, it goes back to the browser. Now in the meantime, that element can be stale. It could have been replaced with another element in the DOM. So there's a good chance, not a good chance, there is a chance you will get a stale element exception. Or you just get the wrong element. So that has a bug, okay? Beyond that, obviously you go to the browser twice when, it's not obvious when you look at the Java.
But we don't know from that example if that element is variable or real element, right?
I'm sorry?
I'm saying from this example, we don't know if element is your variable or real element, right?
So element,
You can make your test variable, which called element, and this element could be equal element from the browser. In that case, you can manipulate it.
but what do you mean element from the browser? So the element is the result of find element, right?
Yeah,
It's a web element.
You have contains all properties, and this one of the properties should be like say text, right? So you don't need to go to the browser. You have already local variables.
Yeah.
It contains objects from browser with all properties of the
So how will the element contain all the properties of the element?
Copy the object, copy the value of the object.
You just have copy of object, right?
How will you have a copy of the object?
You make, let's say, var, let's say, element equal find element, blah, 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 with some expect. You got that object, and this is your local object. You are not related to, you already collected information.
So let me
Now
explain.
you work with your local variable, and you can retrieve all properties.
Your-
of that object,
I
right?
understand. So just to clarify again, I wasn't clear earlier. Your local variable is nothing. It's just the web element, it's just a reference ID. There's nothing there. Okay? So you don't, what you get from back from Selenium is just a pointer, basically. Okay? There's nothing there. There's no content there. If you want to get...
Is it value from an object?
No. You go back to you have the reference ID.
And that's how you solve the still exception. Make a copy of it, get a copy of the static value, a copy of the reference to the dynamic object, and then you compare it with the copy.
I'm sorry?
The stale exception is because you're referencing the dynamic object. right? So if you make a copy of the value of from the object, the text prop, put it in a string object, and then compare that string object to the assertion, that should work.
So I'm not sure I follow. Let me just, you did find element. You got an element, a web.
That element has a text prop, right? Then you make a copy of that string value.
You didn't get a string. You get a reference ID. Web element is just a reference ID. It doesn't have a string. It doesn't have anything. You can copy it if you want. You will copy the reference ID. That's it. There's no content there. Okay?
I can probably explain it. So in the element that got text, it's 1 and 2 in one trip per element, right? That's driving that line element and it's getting that information. And then it has this information, and then getting that text is the next step. So it does that again, and then once it goes back to that element, if the JavaScript refreshes, and that's when you get the Scala element exception. So you might, like one thing that I've done is I'll do a condition, and I'll do a Boolean condition, and maybe try it 3 times. And if that doesn't work, then I have to get some developer to make sure.
Yeah, that's what some people do. So they will try it again and again and again. And that's an approach. The problem with this approach is it reduces the probability, doesn't eliminate the probability. You still have the problem. Okay, so we will talk about ways to eliminate this. Okay, yeah. But I want to make sure that you understand what I was saying. When you get the element from the browser, let's say you get web element.
Let's say I got button, right? I got button with one.
So you did find element to a button.
Yes, I got element button, and let's say my button, let's say local variable. And this button contains all properties, right?
No. The button doesn't contain anything.
Inner text?
Nothing. Nothing. Contains reference ID.
And you can't put that in a string object. String JavaScript, string object.
No, you can't. It contains a reference ID. That's all. Okay, if you want to
You
get...
can't get the value from the object.
You can go to the browser, look at that reference ID number, and get me the attribute for this, the element with this reference ID. It's another trip to the browser. Okay, it looks in Java code, it looks innocent, but what it does, it goes to the browser again, using that reference ID and says to the browser, hey browser, go to the element with this reference ID, and I want to get that attribute. And then when you do get text, you'll get a string. That would be a string at this point, not a reference number, because get text is a string. Okay?
I'm looking at the element equal to John. Everybody got their features like contain John.
Sorry?
I'm looking at the element, your third, that, and yet equal to John. But you have other options like contain or other.
Yes, but that's part of your assertion library. Like in this case, I assume context. So the question was, where does equal to come from, or can you use something else? And in this case, I'm sorry, I wasn't explicit. That assumes that we use something like Hamcrest, or that it's part right now of JUnit. Okay, and equal to is part of that. It's just part of the assertions. So let's take a simple real-world example. So we have a list of names. We want to assert that John is in the list. Okay? So we get the name, we get the elements. What are we getting for? We get an alias with a class name. Okay, that's our element. And then you're familiar roughly with Java 8? Okay, so we basically filter across those elements only the ones that have the text John. and then we assert that we got something. That this list, after we filtered only the elements with text John, that this list is not empty. This code, there is nothing unreasonable in this code. It's perfectly reasonable. I'm asking, do you see any problems here? Again. So I have a question. Let's say we have, let's say it's a table, okay? And we have 100 rows, 100 LIs with names. How many times will I access the browser?
100.
Almost. 101. Why? The first one in the beginning, and then 100 times, because for each one I need to go to get the text, right? Okay, that's very expensive, okay, to go 101 times. Now, we talked earlier, just now we talked about the fact that when we do that, we also risk the stale element exception, okay? Because if some of these rows, they were, here they still existed, then by this point, when I go through 100 times, go to the database, some were just deleted, they are not there anymore in the browser, then I get a stale element exception, and the test is broken. Okay? Now, do you see any other problems in this nice piece of code? So, when does find element, let's say there are LIs with class name, when does it return? It returns immediately. It found one, it found at least one, it returns. So what if the one with, the one with John, the rows with John, what if it took them about 1/10 of a second to appear? Okay? So there were, let's say originally there were 20 rows, and then the additional 10 with John, the rows with John, appeared 1/10 of a second later. What will I get? Will I get them in ELS? I will not get them, right? So then, you with me? Right? So my assertion will fail. But they appear on the screen. We know that they appear. It just took them, 1/10 of a second. So what do many people do? Let's just put a sleep there for the hell of it. Or let's try it again, or something like that. That's not a good approach for two reasons. Number one, it's a probabilistic thing, right? You reduce the probability that you will have a failure, but it's not zero, right? You can still have a failure. And number two, especially if you sleep, it just takes, it takes your test a lot longer. You just completely wasted, let's say, 2 seconds. Now, that's not such a bad thing, but if you have 10,000 tests, that is a bad thing. Now, another option is that, let's say, John is not directly in LI. You have under LI, you have, let's say, a span. It will not catch this, okay? Because that get text is only for the LI. It's not for anything below that. So that's also another problem. What's the error message in case of a failure? The error message is expected not empty, but was empty. Again, that's not a good error message. Yes, you can do, you can wrap it with stuff to make it better, but that's, as it is, it's useless. So some common, you see some, repetition, right? Some themes. So common anti-patterns. Find all the elements, then iterate over them to looking for something. Or let's say you want to take only the 9th element. Okay? So, for example, in our case, we had we got all the rows. Let's say we got 100 rows, and then we looked at row number 20. Okay? So we will do here. We'll do els.get20. That's it, right? If it's Java. The problem with this, we just got a ton of rows that we don't really use. We just throw them away. It's a waste of work. Okay? Another one, find an element, then look for an element under it. It looks great in code. It looks perfectly reasonable, and it's more readable. But the problem with that is your code, it's slower, and more importantly, again, you risk stale element exception. You go to the browser twice. Another variation. The assertion involves several elements. So our assertion wants to, we want to see that the first name is, let's say, Danny, the last name is Loya. Okay, but these are two different elements, so we assert that the first name element has text Danny, the last name element has text Loya. Okay, we go to the database, we go to the browser twice. The problem is not just performance, the problem is that you have a bug here. Because in the modern frameworks, and you're going to see it more and more in the future, they keep changing the DOM. To mitigate, some of those problems, use sleep. Okay, I did this, by the way. It's not like, it's not. I used to do it in the past, or run, try something several times. It's also another approach. Another one, find all elements, then verify the size is 0 or n or bigger than n or smaller than n. Same thing, like we get all the elements and then we just throw them away. We don't do anything with them. Okay? So that's the important part. That's the sentence you need to take out of this, I would say one sentence you need to take out as a takeaway from this presentation. Use a complex XPath to directly access the relevant element that you expect and assert in one operation. Meaning, instead of looking for, let's say, an element, let's say a div with text John, let's looking for an element div and then verify that it has text John, just look for an element div with text John. Okay? So you do it atomically. Yeah.
Question on number 2. If you're looking for an item in a dropdown, how can you not basically find the element and then select one in the dropdown? Especially if that item in a dropdown isn't actually in that same path.
So just to clarify. Obviously, if you have to interact with a DOM, let's say you need to click on the drop-down, and then you see a bunch of things that are actually, usually they're not inside that element you clicked, right? But then you have no choice. You have to first click, and then you have to look for those elements. Completely agree. But in this case, you have no choice. What I'm talking about is something like, well, first let's find the form, and then let's find the section in the form that is relevant to me, and then let's find my field. Okay? But this is the key point. Okay, the key point is that instead of trying to get the element and then trying to find attributes of that element, you declare just as part of the things you want to find on your criteria, your assertion. So instead of get me the element X and then verify that it has class foo, get me the element X with class foo. Okay?
If you have a couple of jobs,
Sorry?
what happens if on your page you have two jobs?
To what? I'm sorry?
Two elements with text.
Two Johns.
Two Johns, I'm sorry. Two Johns.
In that case, you wouldn't get any report and your search and
So what's the difference between those Johns? One is, let's say, one is under the form, and one is in some div, right? Or let's say. So you can add this to your assertion, right? This is what you would typically do. Look for a div inside. Some we will see some examples. It will be clearer. So let's take this example. It's the same example as we had before. Okay, we have a list of names. We want to assert that John is in the list. This is a correct implementation. Basically, you create an XPath that finds an ally, all the allies with class name, like we showed earlier how you find by class, and also string inside it John. Okay? And that's absolutely correct. Okay? And if it fails, it will throw an exception. We still have the problem of that, but this is completely correct. It just atomically goes to the you know that you don't need to run it again and again. It goes once to the browser and gets you exactly what you want or an exception. Obviously, what's the problem here? Problem is that, it's not so easy to work with, right? It's a bit brittle, I would say. Another example, let's say we want just to we want to verify we just have one element, okay? Exactly once with name John in our rows. So you can also put it in the XPath, okay? Just get me the same as before, but also verify there's only one of those elements. Okay? So it doesn't just return one. It returns only if it finds a single one. Otherwise, it fails. It doesn't return anything. Okay, so you see, what we return here is actually the body with some conditions. Okay? Okay, so that's quite powerful. How would you do it, in other ways, in CSS, for example?
I have a question.
Yeah.
Can you use regex to do this anyway? You just find John.
So you could use regex in XPath, yeah.
Not sure.
Yeah, you could use regex in XPath, yeah. But this is, I think it's orthogonal. Here I assume that it's always John, okay? So this is a real world example I had, okay? So, we have, it's a web app, we have a search engine, right? And we have the global search, okay, is an element with class global search. Inside it, we have a group header for each type of element in the results. And each group header has a class, it's a list item with class group header. And then each one of those has a group, each one of the groups has a footer and a result footer. Eventually, if you look inside it, we are looking to find a result where the name has an aggregated text dolphin capital, the class, the ID with the class entity ID has BDD1, has text BDD1, and the type, that's the one with the class entity type, has text hedge fund. Okay, that's what we want to assert, that it exists. How do you suggest to do that? Well, one option, look, we can just use it just step by step. But we also agreed, we already agreed that that's not a good approach, even though it looks good. So what's the approach? We just talked about this, right? The approach is, let's just create an XPath that will find exactly this element, assuming with the condition of all the stuff that we mentioned before. Okay? That's a great idea. So here it is. Okay, that's the XPath. Okay? Yeah. Now imagine that you get something like XPath is not valid. You know, it's very, you know, it happened to many of us. Okay? Then you kind of like, okay, I'm done. I'm going to get coffee. I'm done for today. Okay? Right? Yeah, that's obviously terrible, right? It's very brittle. Maybe it works, but you know, one change and let's get someone to edit this. If you look at the number of parentheses and brackets you have here, it's ridiculous. It's ridiculous. So we have to choose between either maintainable and readable code, but with bugs, okay, or correct and performant, but not maintainable and readable. That's a problem, okay? So that's where we are. So far, any questions? Cool. So it would have been nice, you know, if we could just write an assertion that looks like this, you know. I want to find that a search result that is after one group header and contains the name, ID, and type that we see here is present. That's what we want to assert. Okay? So it would have been nice if I could just write something like this. Okay? The global search, you see, is an element with class global search. And I just write global search is an element with class global search. Cool. And then I can say something like, see, a group header is a list item with class group header. So I can just say element is a list item with class group header. And search results inside the global search are identified by this class. So you can say that the search result is an element with this class inside global search, right? And on and on. You know, you want to be able to say something like, you know, we talk about the name. The name is an element with class that has class name and has aggregated text containing dolphin capital. And then we can assert that the search result, that is after exactly one occurrences of group header. This is exactly what, look here. One occurrence of group header contains the name, the ID, and the type, and contains the name and the ID is present. And this is very similar to this, right? Now, this is where that library that I referred to comes into the picture. Now, what's the difference between this? Why I'm saying this is good, and earlier I said that's bad. The difference here is, these are just declarations. So I'm just declaring the global search is an element. It's not, we're not talking about web element. It's an element, a HTML element with class global search. Okay, I didn't do anything. I just declared what it is. Group header is a list item with class group header. The next one, a search result, I declare that it's an element with this class inside the global search that I just defined. So I just declare stuff. I didn't touch the browser yet. The only place I touch the browser is here at the end. And it's atomic, goes once, boom, and that's it. And notice that this is much more readable. And what we get here, this will create the XPath, the same XPath that we saw earlier. But this is something I can work with, right? So that's the idea. Yeah, that's exactly what I know. It will just work optimally. Yeah. So at this point, I'll stop because I want to explain again that I don't care if you're going. Now I'm going to show you $X. I don't care if you're going to use $X or not. I don't need just a pat on my ego. But I would like you to see a slightly different approach than usual to writing libraries, okay? So, yeah, so if we go back to our simple example earlier with class John, remember that stuff with list items, we want to get all the rows that has text John. This is basically what we want to do, right? Assert that list item with class name that has text John is present in browser. That's actually very nice. That's readable. But here, if it fails, the assertion you will get is this. List item that has class name and has text John is expected to be present but is absent. Okay, this is something I can work with. I know exactly what the problem is. Okay? So this library, $X, does anyone know why it's called $X? Yeah.
That's how you go with XPath.
Yeah, that's the XPath, yeah. That's exactly right. So $X is just how you write XPath in Chrome DevTools. That's all. Nothing, it's not about the money. It's money, I like money. Yeah. So the goals that I had was, since I wrote a lot of tests before, I wanted to write correct code, okay, which is not easy, as we saw. I want it to be readable, maintainable, not brittle, as we saw. I want to get rid of the race conditions completely. I wanted it to be performant. I wanted to have useful assertion and easy troubleshooting. And also be fun to use. And you'll see what that means in a minute. So what is it? It's a DSL. Are you familiar with the term DSL? DSL is a domain-specific language. Okay? It's basically a language that just targets a certain domain, so it can be very specific about its grammar and easier to use. There are two versions, and it has, I claim to have a thoughtful API. That's my claim. You can decide later if it's true. Now, two versions, Scala and Java. I prefer the Scala, but the Java is equivalent, okay? We want to eliminate, as I said, it eliminates completely race conditions and optimizes performance, okay? This is guaranteed. Easy to use and troubleshoot, open source, Apache 2 license. It's on Maven Central, it's in GitHub, works on top of Selenium, so I'm not doing something alternative. I'm using Selenium as a base, and it integrates easily with the WebDriver. So you can go from one to the other if you want. Okay? I didn't want to force anyone to use mine and then just be stuck. So there are three parts in this. The first one is a DOM path builder based on XPath. And it has, it has flexible API. We'll see in a minute what that means. It creates immutable objects. So the approach is very functional, languagey approach. Okay, you create immutable objects, and every time you make a change, it creates a new object, basically for you. Grammar is very much like English, and we'll see example. So we'll see examples. Easy to troubleshoot because the toString returns English, unlike toString that returns, some Java. It's not very readable in many cases. But in this case, toString returns in basically English text, which is nice. Supports almost, I would say, 99% of any XPath expression. And can be used independently. So you don't have to use it with the other stuff. So I know people that used it just to parse XML. They needed something to, so you can use the XPath to parse XML. They just used it to parse XML, not related to web testing at all. Okay, the second part is the interaction with the browser, right? It relies on the path builder of Selenium, and it has two flavors. One supports multi-browser, so you can interact with multiple browser instances at the same time. Typically, that's not what we do, right? Typically, we just interact with one instance of a browser at a time. So in that case, you can use the simplified API for just a single browser, okay, in single browser instance. Next, so once we have the interaction, the next part is the custom matchers. The matchers, as we saw earlier, when we do assert that is empty, which I said, the error message is completely useless. I added a bunch of custom matchers that provide, first of all, they are much more readable. They are more correct because they are guaranteed to be atomic, and they provide useful errors. We'll see that in a minute. It extends Hamcrest and Scala test matchers, if you're familiar with that. And it has two flavors, one for multi-browsers and single browser. So let's talk about the API, okay? And this is the part that I want you to just listen and just try to take it in, even if you're not both on that, that's fine, okay? So if in XPath let's say I want to find span inside div. So this is what I need to do in XPath, right? And in CSS, I need to do div space span, but what I want to find is span inside div, right? So why not write span inside div? That's how we talk. We don't say div and span inside it. We say span inside div. Or alternatively, you want to say span that is contained inside div, or span that has ancestor div. They're all equivalent. In English, they should be equivalent for you to use as an API. All of these work. What I show here is the Java API. Obviously, if you use Scala, if you're familiar, this looks completely like English because you don't have the parentheses and the dot. It just reads span space inside span div. Space div. Okay. Next one. What does this mean? Anyone knows what does this mean? The XPath. It's not obvious, right? It's not obvious what that means. I mean, you need to really know XPath. What about if you read $X there? What does this mean? Div contains span, or div that has descendant span. That's pretty clear what it is, right? I'm looking for div that has descendant span. Okay, so if I'll show you code in a minute. That's much more readable than this. It's equivalent, but this is really not obvious. Descendant : span. You really need PhD to really know XPath well. The next one, we have age1 / following sibling : div. Any idea what that means? It's not clear, right? You really need to know XPath. Like I said, it's not easy. in CSS, I mentioned, you just can't say that. Both of these, you just can't say. But that means, here, this one just means div that is after sibling h1, okay? h1 is, header 1. That's all it means, that's all. And that's how I want to write API like I think about it, okay? I want to find the div that is just after h1. Why can I not write that? Now, let's say if it's not a sibling, let's say just I want the one after h1 anywhere in there. It doesn't have to be a sibling. How do you think it would look like? It should look like div that is after h1, right? And that's exactly what what you would write in $X. So some advanced examples. Okay, let's say I'm not going to go over all of them, but you can do some crazy stuff, like element that has none of the classes foobar or not has child span. This is a really bad, I'm just giving you a contrived example. That's not a great way to write. Or you can write click on button inside my form. Okay, that's fairly easy to understand what that does. Another one, my list is an unordered list that has children, has some children, that's all. Or has 5 children, or has no children, okay? We can continue on and on. Just get me the div before the first occurrence of some element and is also an only child. I'm not going to go over all of these. Yeah, let's talk about flexible grammar. Yeah, now I need to get my ID. Okay, so this is Scala. Okay, this is the Scala flavor. Java is equivalent. So we have do you see, everyone can see this? We have a dialog. A dialog is a div with class UI dialog. Okay, it's a jQuery dialog. Then we have a row with this is a declaration. We don't touch the browser. A row is has a CSS class condition, and it's inside the dialog. Okay. So far we are on the same page. Now we didn't have to say row like this. We can think about row differently, right? We can say what is row? Row has CSS class condition and is inside dialog. Or has CSS class condition and has ancestor dialog. Or is an element inside dialog with CSS, with a class condition. Or, those 20 things in English, they all mean the same thing, okay? So you can just use any of them and they mean the same thing in $X, okay? They're all equivalent, okay? So I'm not forcing you to use, my way, just use it the way you think about it. That's the idea, okay? Now, what's nice about this, if it wasn't clear, is that obviously, when you start, I'll give an example. Let's think if I can find another equivalent. Here, let's do this. Element that, you see, I have auto-completion, right? Because this is Scala. This is like Java. So I can just type, let's say, has CSS, I guess, auto-completion plus condition. And is inside dialog. Okay? That should work, right? I mean, it makes sense. So that works, okay? So they are all equivalent. So the idea is very flexible grammar, okay? My view, you should write, a good API is just removes any obstacles possible to allow you to adopt it quickly. Okay, okay, let's move on. I'll show you. Now, can it be extended? Because we saw there div and some magic. How do I get div? Let's say there's a new element in HTML6 called Fox. Okay, how would we add this element to to my element? I want to refer to it. So I can create an element, a new HTML element, declare like this. Fox, I create a builder with XPath Fox with some explanation of what it is in English, and then I can start using it, div inside Fox. And that, if I print this thing, I'll get div inside my Foxy element. Okay? And you see that makes sense, right? Or if I find, if I want to find, this is a $X thing, right? Find div inside Fox, it will actually look for the path //Fox //div, which makes sense. That's what you would expect. Okay, some examples of interactions. What can you do? These are all valid in action, right? You can click on, click on my button. Let's say you defined my button. Okay, my button is an element. Click on my button, click at my button, hover over some element, double click on button, send keys to element, send keys to browser, press key down, release key, drag and drop element to another element, drag and drop element to some other location, scroll to element, or browser scroll right 100. Sorry, scroll the browser 100 pixels to the right. Yeah. So let's see some examples. We are almost done. So I actually wrote something very, it took me about 2 minutes to write this. And I wanted just for this meetup to do. So if I go to, let's just put the bike point so we see what this does. Okay. Debug. So I go to the meetup site where you see, right, driver get meetup site. Just a second. And I wanted to just play around with the meetup site and see how it, show you how it works. This just takes a while to compile. So. Okay. Where's the browser? Just a second. No, this is not what I wanted to do. Oh. Just a second. Okay. Yep. So it doesn't work well when I do post, So let me just do it again. I'll show you to the breakpoint, and then I'll move it down. Okay. Cool. So here is the oh yeah, finally. Okay. So I go to the site, right, and I want to start to play around with it. Make this bigger. So you see in the site we have this carousel that you can just drag around, right? You know that, and you can just from here drag here. So I want to move it around, let's say. Okay? So how would I do that? Let's say. So I noticed that, make this bigger. An icon in the carousel is a div with class carousel cell. And I'm saying, okay, this is an icon in the carousel. Viewable icon in the carousel has class is selected. So it's an icon in the carousel with class is selected. Now I want to drag and drop the first occurrence of the element, the viewable item in the carousel to the last occurrence. Okay, that's what I want to do. So we're going to run this. Let me just go over it, and then I'm going to run it, because I'm not really, seems that I'm a little bit challenged here. Then what I'm going to do, I'm going to find a tech category, which is here, tech. Okay, basically it's an anchor with class category link, and it has text tech. It has aggregated text containing tech, and I'm going to click on it. I'm going to scroll to it first, and then I'm going to click on it. Once I click on it, it changes screen. So let's just do that. How do I continue? Come on. Why does it not continue? So I'm just rerunning it. Okay. Boom, boom, boom. Okay, it moved. It clicked on the. Now I see the tech category. I don't know if you saw. It scrolled very quickly. It clicked on the tech category. Now I want to find our meetup. So first I want to look here in the drop down. Okay, anchor with text 5 miles. That's what I'm looking for. I'm going to click on that thing. It will get me a drop down. And I'm going to click on 25 miles. Right? So I'm going to look at anchor inside list item with text 25 miles. Then I'm going to the navigation bar here, and I'm going to type Selenium and a new line. And then I expect to get to the Selenium page, right? So if I run it, Selenium, boom. Okay. So I expect to see I expect to see all the results of Selenium. Now I'm looking for a group card that has text containing NYC Selenium, right? So where is it? This is ours, right? NYC Selenium. And then I'm going to click on it. Okay. Okay, cool. Now I get to our page. Now I'm going to find anchor with text Mona Sony. So it's here, right? I'm going to click on that. And I'm going then to click on that anchor inside it, which will get me a picture. Boom, 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 boom. That's it. Okay, and I got the picture. Now, it's very easy to follow what's going on here if I wasn't somewhat challenged, by showing you. But, I can just run it without any breakpoint, and it will do it very quickly. Now, you're going to ask, so what's so special? Yeah, it looks nice, but what's special? So first of all, the fact that it looks nice, it's very good that you can actually maintain this code, okay? And you understand what's going on. It finished. It did everything, it finished, and it exited. So another thing is, it's important to understand the difference between what we did earlier and this. Here, as long as I don't need to touch the browser, I don't touch the browser. In a declaration, so if I declare, for example, what is a tech category, I just want to declare what it is. I don't want to touch the browser, right? That's the big difference. So, the atomicity that we discussed is maintained. It just looks better. So a typical example of a real test, it's like looks something like that. So this is a Scala. A Scala, we also have Java. You can see there are hundreds of examples in Scala and in Java. So if we took this one, we want to Google for Amazon, right? So we declare what is Google. Google is an input inside that search form wrapper that I just declared, and we want send keys Amazon to Google. At this point, the first test just says, okay, I declare what are the results and what's the result link. I want to verify. Remember what I said? Put your assertions in your path. So I'm saying Amazon as first result is the first occurrence of result link, but also has text containing Amazon. And I want to make sure that that is present. So this is the assertion, right? Here, okay? So at this point, I will go to the database, to the browser once, and will return with the results, okay? Some other examples that we have here that are interesting show some useful error. You can run it. I just don't have time to go over this. Here, this is a nice one. For example, I'm feeling lucky. You know the I'm feeling lucky in Google that no one uses, but they still have this option. So you can, so here, we typed Amazon. If you don't remember, I'll show it to you. Okay. Right? If I type Amazon, I should get a drop down here. And here you see I'm feeling lucky. And I can click that and it will take me to that website, the first website that matches this. So what I'm saying is, well, if I'm using I'm feeling lucky, I should go directly to Amazon.com. So I'm saying the first suggestion that you get is the first occurrence of list item inside the form. That's the drop down. Hover over the first suggestion. Once you hover over, you should see I'm feeling lucky, right? So feeling lucky is an anchor inside first suggestion with text feeling lucky. You click on that, and then I just tell it this is the Amazon main title, and it should be present. Now this, remember, what does this do? This will actually go to the browser and will wait until that element is there, okay? Or maybe until we have a timeout, but hopefully if everything works well, we don't have a timeout. So it will wait until it's there, so we know it will pass, assuming everything is okay. Yeah, what did I have here with Warcraft? Yeah, that's, so I said, just another example. I want to see when I type Amazon, this is an example for an error. I want to see that Warcraft is the first result. So I'm saying result link 0 and hashtags for the horde. This is Warcraft as first result. Now notice, I said that we shouldn't use, indexes, right? But remember, this is just a declaration. We did, this is part of the DSL. Okay? We didn't touch the data, we didn't touch the browser. We only touch the browser when we have to, and only once. Okay? Some of those, for example, you have at the top, you see Amazon result must appear 1,000 times or more. Now, how would you do it typically? You would just get everything, right? You would get everything, all the elements, and see that the number you got is 1,000 times or more, the number of elements. But that's wasteful, okay? Because I don't need all the elements, okay? I just need to verify that I have 1,000 or more elements. So you can create an XPath that will check if you have at least 1,000 elements and will return just one element if you have that. So, that the $X is optimized so you will only get what you just want, it will always get you the minimum thing. So this will just return a single, this will just create a single operation, okay? Which is really nice. Considering the alternative. So, yeah, we can continue, but it's, it's late. Where is my... Yeah, okay. Here is a summary. I can send the link to the presentation. The code I showed, by the way, is on GitHub, so you can just download and it just works, okay? You can play around with this. It's kind of fun, I think. You need to have Chrome installed locally just to play around with the examples. It tells you how to run it. And like I said, there are many, many other examples. That's pretty much it. Any questions?
So would it be fair to say that it's just kind of like a wrapper on WebDriver that gives us a lot of XPath?
It would be true to say that it's a wrapper on top of WebDriver. Yeah.
That uses XPath.
That uses XPath. Completely true to say. But it's a pretty big wrapper.
Huh?
Yes, but it's a pretty big wrapper.
Yeah. So you gave examples of like, I want to find something in a list and I don't want to traverse through the whole list. What if you do want the whole list and you gotta check every item on the list, like John's first? Does this handle that, or
Yes.
how would it?
Yeah.
Do I still have to grab all elements or traverse through the elements, or just right one?
So if you, what are you looking for?
Let's say I have a list A, B, C, D, E, all the way to C, right? And I want to verify that list in that order.
Yeah.
It'll just write one giant XPath that will do that.
No, there's an API for that. You can say, I want a list where this is the first element, this is the second element, and this is the third element, and it will create a massive XPath.
Yeah.
But from your perspective, you don't care. You don't need to know that. Okay? So from your perspective, you just use that quite readable API.
Yeah. So I guess a lot of this is putting all the processing on the XPath engine of the browser, right?
Yeah.
So again, I guess that goes back to my original concern of performance. Like, is it going to depend on what browser I'm using? Is IE going to suck? Is Chrome going to be awesome?
So I used it a lot. It's performant. It's very, compared to not using it, obviously, anything you can write with $X, you can write with WebDriver because it's just, on top of it. But I would say that the main punishment that you get, the main problems, is from things like sleep, things that you retry, things that you get many more objects that you should get, stuff like that. These are the main penalties. So yes, it can create XPath that's not optimized. That if you wanted to, and you're really good with XPath, you have a PhD in XPath, you can create a better XPath. The question is, do you want to do? If you're an expert in XPath, by all means, go write in XPath. But what about your colleague? He also needs to read your code.
Yeah, that's understandable. Yeah, I mean, the layer initially is simple. I mean, it's readable. It's just, my concern is behind the scenes that you're really dependent on, whoever wrote that library, how good is their XPath? Because I'm not writing the XPath, right? That library's coming up with the XPath.
So, right, but that's the whole point.
Yeah.
We saw that gigantic, ridiculous XPath there, right? And that's a real scenario. That's something that happened to me. And either you deal with that, or you write an abstraction layer, right? That's what we do in developers. We write abstraction layer. Okay. I don't want everyone to feel the pain of dealing with XPath, and there's a huge cost to that. So yes, you need to rely on $X, correct? But that's true for any. First of all, you don't have to use $X, but let's say you use $X. You can. So first of all, it has like a gazillion tests that you can verify that it does everything that you expect it to do. But also, we rely on libraries. That's what we do. We are developers. Any questions? Yes.
How do you handle this element for, let's say, an action for clicking something?
So remember I showed.
That was the text. I was getting a text. How do you do, like, let's say, you get the text, you have all the information, but now you want to click on it.
So let me just show again. I click and scroll and drag and drop here. Remember that, the meetup stuff? So look here, I scroll through the carousel. I drag an element in the carousel to another element. I scroll, I click, I send
This is all one action? This is all one
No, in Selenium, you can't just, there's no way in Selenium atomically to do, no, there's no way to do that. You have to, every operation is an access to the browser.
Yeah, so you found it and then you clicked it, right?
Yes.
So how do you deal with the stale element?
So this is not something that, even if you use the newer API by Selenium, it doesn't offer you another option. It doesn't offer you an option, just find and click. Just.
No, I'm asking how do you deal with stale elements that, let's say, they get accepted too fast. So because you're doing hits either way.
I don't deal with that.
All right.
Just there's no way to deal with that because, but let's just do an example. Let's say here, okay. And let's say this is this phi, this times. Okay, so if we run this thing, okay, it will obviously not find this, right? It's this rubbish. So, it could have been a stale element also, right? So, just a second. Okay, I got an error, right? Let's say it could have been a stale element. Just want to. Why can't I? Oh. What? No. All right. Okay. So here it is. Right, this is the error you got. Could not click a distance drop down. And then you get caused by could not find distance drop down. That's useful. At least you know what the problem is. So let's say it was a stale element. You would get something like this element, I can't find it, and it's a stale element. But what you get is something that you understand, right? You saw what, I'm sorry, why did I click this? You got something in English, could not find distance drop down. But yeah, if you're talking about, there's no way for me to bypass what Selenium exposes, okay? And I don't want to, because I want to allow a user, let's say if something, they don't want to use my library, they just want to use WebDriver, you can just use WebDriver because they work together. Okay, I think that's, yeah, that's more useful than completely saying, I'm going to create something entirely new.
It's really cool. It's very readable, very nice work. It's fast to keyboard notation. It's for performance as well. But did you measure what is a kind of profit in performance? What is the difference, shooting server and having one multiple times, or have send request just one time? What is what will it kind of gain?
What would be the gain? That's a tough question because it depends on so many things. It depends where your browser runs. For example, do you have a Selenium farm like SourceLab, or do you have a local browser? How complicated is your XPath? Depends on many things. I can't say. It is significant, though. In all cases, obviously, if you go to the browser twice instead of once, it's slightly slower. Yes, you go 1,000 times instead of 10. That's a lot more significant. So, yeah. I can tell you that we had problems, we are very much into automatic testing in Lab 49, and we had problems because it took forever to run the behavior test. It took us 5 hours to run the behavior tests. And that was crazy, it's insane. And, after we converted to this, it became like 30 minutes. But it's also more correct. In 30 minutes, but also more correct. That's a big difference. So, yeah. However, again, don't use $X if you don't want to. That's fine. Just remember all the stuff that we talked about. Okay, what not to do.
It's good to try.
Okay. Okay. Thank you very much.